Thanks for joining me for this video. I'm going to show you how to simplify rational expressions, and then we're going to talk about defining the domain when you have a rational expression. So for the first four, we're going to simplify these. What you're looking to do is you're trying to make sure that the numerator and the denominator are both factored. Because if they're factored, meaning a product on the top, multiplication, and multiplication on the bottom, you can cross out or divide out common factors. If you remember when you were reducing fractions, let's say you had 10 over 15. 10 you could rewrite as 5 times 2, and 15 you could rewrite as 5 times 3. So 10 is factored into 5 and 2. It's multiplied together to get 10. And 15 you could write as the factors 5 times 3. Well, 5 divided by 5 is 1. Those divide out. So now you just have 1 times 2 on the top, and if you multiply those together, you get 2. And on the bottom, you have 1 times 3, which is just 3. And so 10 over 15 reduces to 2 over 3. And so by writing it in factored form, you can see that you can divide out a common factor and reduce your fraction. That's all you're trying to do in these examples, 1 through 4. You're trying to reduce these fractions, and in order to do that, you need to write them as factors so that you can cross out a common factor. Those divide out to be 1. So if you see in number 1, this one is already factored. So if you look, you can see that in the numerator, I have a 3x minus 1, and there's not a factor that is exactly like that in the denominator, so that one's going to have to stay. But then I see an x plus 2, and if you look, you see there's an x plus 2 in the denominator as well. So since those are identical, those will divide out and leave a 1 in their place. And remember that anything times 1 is just itself. But I just want to make a note of that they divide out and leave a 1. They don't cancel and leave a 0. So then we are going to see what we have left. And on the top, we will have 3x minus 1. And on the bottom, we will have 5x minus 1. Now, you might be looking at this thinking, oh, I could cross out the negative 1s because those are the same. That is not a valid thing to do. You can't cross out something if it's attached to something else with a plus or a minus sign. Think about it this way. If you had 3/4, that's equal to 0.75. What if I added 1 to both of these? Well, that would now be 4/5. Well, 4/5 is equal to 0.8. So I can't just cross out the plus 1s and say, oh, it's the same fraction, because it's not. You cannot cross out or divide out something that's added or subtracted to something else. You can only cross out an entire factor. So 3x minus 1 goes together as an entire factor. You can cross it all out, or you can't cancel anything out from that. So you can't cancel out just a piece of a factor. It's all or nothing. So if we look at number 2, x squared minus 16, that's together as one factor. That minus joins it together. But you can try to break it down further. So x squared minus 16, that's a difference of squares. That can factor into x plus 4, x minus 4. The denominator, I see an x squared. Right now, it's a trinomial. I have to cancel the whole trinomial or nothing. But I could break it down into 2 factors. So x, what multiplies to get 4 and adds to get negative 5. So that would be a negative 4 and a negative 1. Now notice that I have 2 factors on the top and 2 factors on the bottom. So I can cancel my x minus 4 on top with the x minus 4 on the bottom. That leaves me an x plus 4 on the top and an x minus 1 on the bottom. Can you cancel these x's? The answer is no, you cannot, because the x on the top is attached to that 4. X plus 4 is a factor. It's one thing together. So you can either cross the entire x plus 4 or nothing. So this is my answer right here. This is the simplified fraction. All right, let's look at number 3. So number 3, we have an entire polynomial or trinomial on the top. Since it doesn't match the bottom, the only thing I can do is try to factor out something. So if I look at the top, I'm looking at the 9, the 18, and the 9. I can see that they all have a 9 in common. They also all have an m in common. So the first thing I want to do is factor out a 9 and an m because that is a common factor. If I factor out a 9m, I will have m squared plus 2m plus 1 left. On the bottom, I also see that I have a common factor, 3m, so I'm going to factor that out. And if I divide out a 3m, I'm going to have m plus 1 left on the bottom. So I took out a 3m and I have m plus 1. Okay, so now I want to see if I can factor what's in parentheses further. The bottom I'm not going to be able to because I don't have an exponent on my m, so the bottom is done. But the top I can factor that m squared plus 2m plus 1 again. So I'm going to do that. So m, what multiplies to get 1 and adds to get 2? Well, that will be 1 and 1. All over 3m times m plus 1. So now I have everything factored. Notice on the top, I have 4 factors. And if you didn't see that, maybe you said 3 factors. 9 is 1 factor. M is a separate factor. M plus 1 is a factor. And then I have another m plus 1. So all 4 of those are factors. So there are 4 factors in the numerator. And in the denominator, I have 3 factors. 3 times m plus 1. So 4 factors on the top and 3 factors in the denominator. If any factors match exactly, I can cross those out. So I have m plus 1s. Those match exactly, so I can cross those out. I have an m that's by itself in blue. Those can cross out. The m plus 1 that's yellow, that's going to have to stay on the top because I don't have anything to cross it out with. But notice in red, I have a 9 and a 3. I can reduce those both by 3. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Notice that everything I cross out, it leaves a 1 in its place. So in the denominator, all I have left are 1s. 1 times 1 times 1. So the denominator is going to be 1. Remember, if your denominator is 1, you don't actually have to write a fraction. So I'm just going to have the numerator. So 3 times m plus 1 is all that's going to be left. So you can leave your answer like that, or perhaps you will want to distribute the 3, and that's fine as well. So you will get 3m plus 3. All right, let's look at number 4. So number 4, we want to try to factor. There's not a greatest common factor in the numerator, and there's also not a greatest common factor in the denominator. So I need to factor these. Notice that both of them are going to be the factor by grouping technique or the AC method. So let's see, 6n squared plus 5n minus 4. So we want to know what multiplies to get negative 24 and adds to get 5. So 1 times 24, 2 times 12, 3 times 8. Okay, 3 and 8 is going to work. So if I use a negative 3 and a positive 8 and multiply those, I will get negative 24. And negative 3 plus 8 is 5. So that will work. So we're going to bring down the 6n squared. We're going to split the 5 up into the negative 3n plus 8n. And then we're going to bring down the minus 4. Factor by grouping, we'll have 3n. So we'll have 2n minus 1 left. Bring down the plus. Factor here, we have a 4 in common. When you factor out the 4, just as a reminder, you're dividing out your common factor here. So when you factor out the 4, you'll get 2n minus 1. When you're doing this factor by grouping technique, the things that you get in parentheses should match, and they do, so that's a good sign. That means it's factorable. So my numerator factors into 2n minus 1 times 3n plus 4. So 2n minus 1 times 3n plus 4. Let me move that up a little bit here. Okay. All right, so the next one I need to factor is the 3n squared. Let's see. 3n squared plus 19n plus 20. So I'm going to have to do the same technique here. So it multiplies to get 60 and adds to get 19. All right, so 60, we have 1 and 60, 2 and 30, 3 and 20, 4 and 15. That's going to be what works. So 4 times 15 is 60, and 4 plus 15 is 19. So I'm going to use the 4 plus 15. So 3n squared plus 4n plus 15n. Bring down the 20. Greatest common factor with the first pair is n. So that's going to be n times 3n plus 4. Bring down the plus. Greatest common factor with the next pair is 5. And then when I factor out the 5, I get 3n plus 4. So good sign that the parentheses match. So 3n plus 4 and n plus 5. So if you're not comfortable with factoring, you need to make sure that you go back and practice that, because you're going to be using it so much in the next few sections. When you're working with rational expressions and rational equations, you're going to be factoring a lot. So if your factoring is not strong, I would really recommend taking some time to go back and relearn the factoring techniques. All right, so now that that's factored, notice that the 3n plus 4 is on the top and the bottom. So those will divide out, and it will leave us 2n minus 1 on the top and n plus 5 on the bottom. Those are not alike. They're not like terms, or I should say they're not common factors. So they won't divide out, and that will be the simplified version of the original rational expression. All right, the next topic for this video is the domain of these. So what you want to remember is the denominator of a fraction, let's say something like this, cannot be 0. So it's undefined. You can't divide by 0. Sometimes people forget if it's 0 or not. So for example, this is 0. So a professor once taught me a way to remember it, and it helped me a lot. If a 0 is on the bottom, it's a no. It's undefined. If a 0 is on the top, it's okay. That's 0. So if that helps, great. But the 0 on the bottom is a no-go. It's undefined. So that being said, a rational expression is a fraction, and it has a variable in the denominator. When it has a variable in the denominator, you want to make sure that you keep in mind that when you start solving these equations, there are certain values for x that can't happen. The simplest idea here, or the simplest version of that, would be if I had something like 3 over x. If I had this rational expression and I wanted to know what is it not okay for me to sub in for x, well, x cannot be 0, right? If I say, hey, x is 0, then that's going to make the bottom be 0. And I don't want the denominator to be 0. So x cannot be 0 is a restriction. Remember that x and your domain go together. So your domain is the set of all possible x values. When you have a fraction, your domain is restricted. It can be anything except what will make the bottom 0. So in order to find your domain in a little bit more of a complicated case, like 5, 6, and 7, what you want to do is set your bottom or your denominator equal to 0 and solve and see what the problem values are. So in a fraction, we don't want the bottom to be 0. So bottom cannot be 0. Your denominator cannot be 0. So what you want to do is you want to go ahead and actually set it equal to 0 and see what values would be a problem. So if I did that, I would solve this equation. I would add 5 to both sides, and I would see that x equals 5. Notice that if I plug 5 in, 5 minus 5 is 0, and that's exactly what I don't want to happen. So by setting the denominator equal to 0 and solving, you're finding your restriction. So find the restricted values. The restricted value here is 5. So x cannot be 5. Number 6, set the denominator equal to 0 and solve. So since I have 2 factors in the denominator, that means I'm going to have 2 restrictions. So x minus 3 equals 0 will lead to my first restriction, and 2x plus 1 equals 0 will lead to my second restriction. So when I add 3 to both sides here, I will get x equals 3. So x cannot be 3 because that would make the bottom 0. Subtract 1 from both sides, so I get 2x equals negative 1. Divide by 2, so x equals negative 1/2. So x cannot be negative 1/2 because that would also make the denominator 0. So my restrictions for number 6, x cannot be 3 or negative 1/2. And then finally, number 7, same thing. So it doesn't matter what the denominator looks like. And notice that I don't even care about the numerator. If I'm talking about restrictions, I'm only looking at the bottom, the denominator. So no matter what the denominator is, it's the same process every single time. I set the denominator equal to 0 and solve. So this is a quadratic equation. I'm going to solve by factoring. So what multiplies to get negative 6 and adds to get negative 1? That will be negative 3 and positive 2. Again, notice I'm going to have 2 restrictions here. So x cannot be 3 and x cannot be negative 2.